Syed I'm doing a PhD in nuclear engineering. It's under Engineering Design Center at Cambridge. It's a group of almost 15 people, and it's known as Cambridge Nuclear Energy Center. I should mention that I did my master's in nuclear energy last year in 2012, and this is kind of extension of my work. In my MPhil, actually, I just designed a nuclear reactor core for, it's a kind of light water reactor, so it's a kind of extension. So I just started my PhD just 2 months ago, so not extensive results like you. So okay, I'm starting. My topic is design of nuclear reactor cores for civil nuclear marine propulsion. I will not go to very extensive detail or scientific detail. Rather than, I prefer to tell you about more simplification that as you can understand the things. So, what's the motivation? For every research things, you should have a motivation that, yeah, I'm doing this for a certain reason. So, what's the reason of doing this research? So, the general question is that, why actually I'm using this nuclear propulsion for the civil ships? Actually, I should mention that the nuclear propulsion normally now being used in the military ships, but our plan is to implement it in the civil ships. Then the next questions are, if we implement it in the civil ships, will it be environmentally good? Number two, will it be economically competitive with the other technology that is being used presently? And my design question is, if I implement this technology to civilian ships, will it be technologically feasible considering lots of reactor physics aspects? And considering the security criteria, as you know, nuclear is a kind of security concern around the world, and it sometimes creates alarm in our mind. Will it really be secure in the nuclear propulsion, in the civil implementation? And finally, some physics more topic. How will it meet the design challenge of soluble boron-free reactor core with long core life and low enrichment? Let me just have a glimpse on this. Actually, soluble boron-free core means, we know nuclear reactor, the thing actually I'm designing is a core that is kind of, you can tell, nuclear battery. Okay, so in every nuclear reactor, we need some control things. Normally in nuclear reactor core, generally in the land-based nuclear reactor core, we use soluble boron to control the fission. Because if the fission is not controlled, it creates a devastating effect. So, but in the ship, or in the reactor core that will be in the sea, we cannot use the boron because of the boron dilution accident. That means if the boron dilution accident is happened in the reactor core, it cannot be controlled, and there are lots of bad effects of coolant and lots of parts in reactors. Okay, and another thing is that long core life, and as it will be in the ship, our expectation that the core life will be more than 10 years. But the problem is that for making the core life longer, there is a criterion physics that we need high enrichment. But for civilian propulsion, we can't allow more than 20% enrichment. So we need low enrichment for this project. And the main difference between it is the land-based reactor system and it is the sea-based reactor system. Actually, everything is same. Because of the fission, it creates huge steam that drives the turbine, and it creates electricity, generates electricity in the land-based. And for the reactor compartment in the sea-based ship, it just rotates the propeller. That's the difference. And the motivation I described earlier is that my design should be environmentally friendly and economically viable. Moreover, it should be proliferation resistant. That means I can make bomb. Finally, my aim is to produce a reactor core that will produce safe and reliable power. And the design criteria I mentioned you earlier in my motivation is that it will be low enrichment of less than 20%, long core lifetime, what I mentioned. The main important thing I missed is that it will be small reactor core with integral type. Integral type means in the land-based, all the components are separated, but in the reactor that will be in the ship, all the parts will be integrated. And the main criteria is that my aim is not to design the things only. I have to design an optimal layout which will be fitted and produce the best results. Finally, my steps which I'm investigating now, I can brief in 10 seconds that first I will design initial assembly. Then if it works, then I will go for a 3D assembly, and then I will design a burnable absorber because I'm not using any soluble boron for control. Then finally I will make a 3D whole core reactor and analyze the results. Thank you. You can ask me questions if you have.
Thank you very much. So any questions?
Sure.
So if you're not using boron, which material are you going to use?
Actually, I'm not using boron, so I will use burnable absorber. Burnable absorber actually kind of zirconium boride, or normally in the industrial use now, IFBR, integral fuel burnable absorber. It's a mixture of zirconium, zirconium and erbium oxide. This actually reduce the excess reactivity in the beginning of life, which is wanted in this research.
Yeah, as far as I know, the coating borax melting temperature is really high, so it's solid in room temperature, right?
I'm not sure about the chemical component about it, but now Westinghouse, that prototype we normally follow,
Yeah.
Westinghouse is using zirconium boride and integral fuel burnable absorber.
Yeah.
Temperature is 700 degrees Celsius.
That's a working temperature, right?
Yeah, working temperature. So it works in the temperature. So my aim is investigating zirconium boride in place of soluble boron.
Okay, I'm going to stop you there. Thank you very much. What does everybody